हेलो स्टूडेंट्स, वेलकम बैक टू माय चैनल जिसका नाम है वीएस मैथ्स एकेडमी, मैथ्स इन अ वेरी सिंपल वे. सो टुडे आई हैव कम अप विथ न्यू टॉपिक from matrices, that is rank using normal form and PAQ normal form. So again, as an exam point of view, if you see, this is very important topic. Okay, there will be definitely one question on normal form and PAQ normal form. PAQ normal form mostly 8 marks question, or normal form 6 to 7 marks question will be asked. So for exam, this is one of the very important topic and can be studied in a very less time, short time. So today we are going to do the same. We will very quickly go through what is the difference between these two forms, that is normal form and PAQ normal form, and how to tackle the examples in the exam when they are asked. So let's start quickly. Before that, if you have not subscribed my channel yet, please do so, because I'm bringing different topics every day to make them simple for engineering students and even for the others, for all semesters. So you can refer to those topics, and whatever videos I upload you will get to know soon. So let's start without wasting a time. Then first we have to know what is a rank using normal form or canonical form. So what is it? What is this rank? Okay, so in a very small example I'm going to explain. So suppose if we take any matrix. Okay, suppose we have a matrix A with random entries. Okay, I will take the entries A1, B1, C1, A2, B2, C2, and A3, B3, C3. Okay, I am taking a 3 cross 3 matrix. So here see, I have taken a 3 cross 3 matrix. Then we need to, what we need to do in this normal form or PAQ normal form, we need to convert it to matrix similar to identity. Okay, now what I mean by similar to identity, that is, see, why I am not saying identity. So a matrix A can be converted to identity 3 cross 3 matrix, or it may not, it may come to similar. I will tell you, I'll explain. Okay, so basically 3 cross 3 matrix, we need to convert it to a matrix which is similar to identity. That is, 3 cross 3 matrix given to you, it may turn up in this 3 ways. Like first, that is, it may turn up to this identity matrix, or it may convert to like this, where see, you can see here I2, okay, 2 cross 2 identity in upper part, and then other places you are getting 0. Okay, or you may get like this, where only you will find only 1 cross 1 matrix identity, that is I1 only in the first part, and everywhere else 0. So your 3 cross 3 matrix given may get converted to these 3 similar forms. Okay, so I am not saying that you cannot always convert to identity, but you can convert to similar to identity. And 3 cross 3 matrix given may turn up to all one of these 3 cases which I have listed here. These are called the normal forms of given complex number, given matrix, normal form. So your matrix will turn out one of this, okay, not all at a time. So matrix is going to turn out only one of this. So if it turns out to be identity I3, then in this case rank 3, we say rank is 3. If it turns out this, then in this case rank 2, and if it is like this, then rank is 1. Okay, so like this the rank is decided using normal form. So what we have to do, given matrix we need to convert to become like one of this. And how are we going to achieve, how to achieve this? So what we have to do for that, we have to use, so we need to use, how are we going to achieve? We need to use elementary transformations in matrix. Okay, elementary transformations are row transformation or column transformation. Similarly, one more way I will explain. Suppose your matrix is B matrix. Okay, so here see, I have considered a 2 cross 3 matrix, right? So 2 cross 3 matrix, if you convert, so if you convert this matrix using elementary row and column transformation, you can get only two possibilities, like uh, because here it is a 2 cross 2 matrix, you can get identity of order 2 at the max, and the extra entry will be 0. Okay, I will just write like this. Okay, yeah. So this, or what you can get is identity matrix of order 1, so only 1 you will have, and like this. Okay, so in this case, if you see, this is the identity matrix that you have, and hence a rank will be 2 in this case. And here if you see, this is the identity matrix of order 1, so rank is equal to 1 in this case. All extra entries need to be 0. So like this, the most important point that we can note here is the rank of any matrix is always less than or equal to minimum of number of rows and columns present in the matrix. Okay, columns or number of rows. So this is a very important thing. So here rank can be 2 and 1. So this is how in square matrix or any random matrix the rank is found out. So here now we will see the examples quickly, go through the example, and I am going to make you learn what is the difference between normal form and PAQ normal. See, both are actually the same steps we are following in both the forms. Okay, still students will be confused between two forms, so there is no need actually of any confusion. We will just see one example. I will do it for normal form, and the same example I will also do for the PAQ normal form, and you can clearly note the difference. Okay, so let's start quickly. So before going for the example, I will just give you the steps which to be followed, or the sequence which to be followed, so that we will definitely reach to our normal form in any example. Okay, actually you can follow the steps as per you see the example. Sometimes the steps will be very quick and easy, but I have seen students struggling for the easy way, and they don't even get the answer for the simple problem. So better you can just keep on following this particular pattern, and you will definitely get the answer in all the example, instead of just struggling to find the easy steps. Okay, so what is the step 1? You have to convert. Okay, convert a11 to 1. Okay, so that means you have to first make this a11 entry as 1. Make a11 as 1. So for this you can use any row operations, column operation, that is any elementary operations you can use. You can do the exchange, you can do the subtraction. I hope all of you know elementary operations, right? So you can do that and bring a11 as 1. This is our first step. Second step, what you have to do is, using this a11, you have to make all the entries in that row, okay, and in the column 0. So using a11 equal to 1, make all entries in the row and column 0. Okay, so you have to convert all the entries to be 0 using this a11. So obviously you will have to use the row operation, column operations, like that. So we will explore that in example. And third, then again, once you have converted a11 to 1 and all the entries here and here 0, okay, that is, you will be getting some form something like this, okay, and you will be having your matrix here onwards pending. These entries I am not writing a22 like that because they will be now changed, okay, but some other entries. So next you have to focus on a22. Now convert a22 as 1, okay, and again using this one you have to make this entries and this entry 0. So you have to follow the sequence, okay, using a22 1, make all entries. So using a22 you have to make all the entries in that row and column 0, and then you have to proceed so on, okay. So this is the sequence. If you follow, definitely you will reach to the normal form or PAQ normal form, okay, instead of struggling. So now let's explore this with example. So as I said, we will explore with the example. Here I have considered the example of a matrix, which is you can see 3 cross 4 matrix here, and we will see its rank using normal form and PAQ normal form both, okay, normal form and PAQ normal. So let's first focus on a normal form. I will show you comparatively side by side in the both way, so that it will be very easy for you to note the difference between the two forms, okay. So let's first start with the normal form. So in normal form, as I said, the step 1 will be to have a11 as 1. So here a11 is already 1. So next what we have to do, using this a11 we have to make all the entries in the same column and same row 0, okay. So in order to make the entries in the column 0, okay, the elementary operation that I will use is r2 minus 3 r1, okay, and to make r4 3, okay, I will be using r3 plus r1. So like this you can use two operations in a single step because you are operating on two different rows, okay. This is very important. So see, if we do this operation, this is what we get, this is the matrix that we get, okay. So next what we have to do, see, calculation part I am skipping for you. So next what we have to do is we have to make now this row entry is 0. So how we can achieve that? I can do C2 minus 2 C1, I will do C3 minus C1, I can do C4 minus 3 C1, okay. Like this if I do, then I will be getting, by this column operations, I will be getting this entry as 0, I will get even this entry as 0, and I can achieve this entry also as 0, okay. So this is going to be my next step. Now let's proceed for the next one. So here now what is our next target? Actually we have to make this entry as 1. So for that purpose what I can do is I can do r2 upon minus 2, okay. I can do r2 by minus 2, or I can even do C2 by minus 2, okay. It is up to you, any row or column operation you can follow, but I have followed the row because you can see all the entries are divisible. So 1, 3 and 5, this is what we get, 0, 2, 6, 10. Now next motive is using this 1, okay. Using this 1 we have to make this entry 0. That is what we will achieve in the next step. So for that I will be writing r3 minus 2 r1, 1. Now I was talking that sometimes you can use the easy steps, okay, you need not follow the sequence. So that is what is here. If you observe, you can directly would have done r3 plus r2 and you would have got the 0, but that happens in a rarely cases, okay, that you get readily something like this adjustment and directly getting it cancel. Otherwise the normal procedure is you have to convert it to 1 and then make it 0. So if you do that, then you can see that here we are getting the 0. Now next is you have to make these entries 0. So for that purpose I will have to do C3 minus 3 C2 and C4 minus 5 C2. Okay, if I do so, then I will get this as 0 1 0 0 0 0 0 0 0. Okay, do you see that our matrix has got converted? And see, as I showed you, the matrix has got converted to identity, similar to identity. And do you see which identity you have got? If you note, you have got I2, okay, and all extra entries are 0. So this is what you have got. You have got 2 cross 2 matrix. So we will be writing rank of the given matrix is 2. Okay, so this is called normal form. So here that which form you have got is a normal form of matrix E. Okay, so you have seen how easily we got rank using normal form. Now we will see this same using PAQ normal form. So look here, for PAQ normal form, the first step is important step. Okay, very important step. What is the very important step that we have to write? We write given matrix A as IAI. Okay, this is the important step that you need to. What is this IAI? We know that any matrix is equal to identity into A into identity. Okay, so if you multiply matrix by identity, it is same matrix. But whatever you have for matrix multiplication, whatever matrix you are multiplying it is will be of order 3, and this is the post. Okay, this is pre identity and this is post identity matrix. Okay, so this is how we need to start. Okay, so here I have just replaced the values, and now what you have to do, you have to do the same steps which you have followed here, okay, to get the normal form. So exactly same steps I am going to follow here. If you see, I have done r2 minus 3 r1 r3 plus r1, same I will do here. Okay, r1 and r3 plus r1, same steps we have to follow, and hence the left hand side matrix will be same as this. Okay, you can just see 1 2 1 3 and 0 minus 2 minus 6 minus 10, and this will also be 0 2 6 and 10. Now what is the difference in the PAQ normal form? That is important. So what you have to do, you have followed row operations, right? Row operations. So whatever row operations you have followed, that you need to repeat on right hand side. You have to repeat on this pre-multiplied identity matrix. So here on pre you have to do this row operations. So same row operations I will continue on right hand side, that is on this pre-multiplied identity matrix. So R2 minus 3 R1 will result in this, and R3 plus R1 will result in this. Rest of the things need to be copied as it is. You see, I have not changed this one because I have done row operations, so it has to be multiplied, it has to be repeated on pre-multiplied identity matrix. Now next, again we will proceed in the similar way. You just see what are the steps that we did. After that we have done a column operation. Okay, that is C2 minus 2 C1, then C3 minus C1 and C4 minus 3C1. Okay, so same operations I will be doing here. So left hand side matrix will be converting to this. Okay, 0 minus 6 6, 0 minus 10 10. And now on the right hand side what we have to do is, now because this is column, okay, this is column operation, so we will not touch our pre-multiplied identity matrix. We need to copy it as same what is given. Okay, note these steps. We will copy even A as it is, and now column operations to be repeated on the post multiplied identity matrix. So we will carry out all these operations on this particular matrix and we will write the result. So result here is, okay, so if you perform column operations, this is what you get. And now the next step, see here again we have done which step, we have done R3 minus 2, sorry, this one we did. So R2 divided by minus 2. Okay, so what we get is like this. So here you can do 1 0 0 and minus 3 by 2 half 0 1 0 1, and the rest you have to keep same. Okay, because row, it is row operation that was, so here we will be operating and not here. So this will be copied as it is. And see here, I have shown you a sequence. Okay, so I am dividing by minus 2 to get okay, I have divided by minus 2, wait a minute. Okay, so this plus and minus I will be getting. So here I showed you a proper sequence, okay, which is followed usually in all the examples, but here as I told you that here it was simple to just add these two rows and bring the 0. And if you would have done that by that procedure, so here also you will not be getting fractions. Okay, but now as I want to show you one uniform technique, okay, I am going to proceed with the fractions. Anyway, the answer doesn't matters, whatever you write in PAQ normal form, whatever steps you follow, accordingly you will be getting your P and Q. So this is very important to note that a person following different steps to get normal form will be having different P values for P and Q. Okay, students getting confused in this also. I have seen many students get confused. They feel that everyone will get same P and Q for every sum. It is not like that. You will be getting different P and Q in different case. Okay, in different means if you are following different steps. So now I will do R3 minus 2 R2. See, same steps you can just go on continue. What is the difference? Do you know? Are you noting what is the difference? Difference is just that in PAQ normal form we are keeping a track of whatever steps we have followed on. Whatever steps we are performing on left hand side, we are repeating same on right hand side. Okay, as per row and column. So here again I will do the calculation and replace the value. So see, we just need to go on following the same steps here, because row operation this was, we have repeated on this pre-multiplied matrix, and post-multiplied matrix we have to copy as it is. Now let's proceed further. So here I have performed the last step also. You will see this is the column operation, okay, that we have performed. So we will repeat it on this post multiplied. This we have copied as it is, and A as it is. So like this, and this is the end. Okay, so how to declare now the rank from here? You just see same way we have got this I2. Okay, from here 0 0 extra entries, and whatever we have got here, this is P, this is A, and this is Q. Okay, so this is the PAQ normal form, and rank A is 2. This is how we need to answer. Okay, so simple. You have seen comparatively how we have done. What is the difference between two? Okay, it is just keeping a track properly. And what we have to note while keeping the track: rows pre-multiplied matrix, rows to be performed, and column on post multiply. Okay, and like this you can continue. So left hand side will give you normal form. This is normal form of a matrix, and right hand side what you get is PAQ. So total it is called PAQ normal form. Okay, so we have finished the comparison and topic here, but just for your information I would like to tell you one more thing, that from PAQ normal form you must have heard that PAQ normal form you can also find the inverse. Okay, so you can find the inverse if your A is having full rank. Okay, full rank, like if A is 3 cross 3, then rank should be 3, and rank A is 3, implies inverse exist. And what is the inverse? So A inverse can be given as Q into P. Okay, so what you need to do, that your Q and P you need to multiply. Okay, in the reverse order, Q into P, you will get A inverse. So this is very important, but it can be done only if A has a full rank. That is, if A is n cross n matrix, it should have rank n. It cannot be done for any less rank, like for 3 cross 3 matrix, if it is rank for 3 cross 3 matrix, if rank is 2 or rank is 1, then inverse does not exist. Okay, so this is just for your information, and that's it. So here we will stop for today, and all the best. Again I will request you to subscribe my channel if you have not yet, and be there with me to learn the mathematics concept in a simple way.